Hi, this is Richard C. I'm a math tutor here at Wyzant, answering a question submitted by a student who's obviously taking trigonometry right now. And this is basically just a unit circle problem. So I'm assuming that he or she is studying unit circle right now. Oh, no, this got cut off. The equation here got cut off. I'll write it down beneath the problem. How that didn't come across when I pasted it in. Anyway, we want to solve this equation. Cotangent Okay, so the cotangent of theta looks like the square root of 3 cotangent of theta plus 1 equals 0. So we subtract the 1 and divide by root 3. So it's going to be 1 over the square root of root 3 negative 1 because you're subtracting the 1. That's our cotangent of theta. And I prefer to work with tangent rather than cotangent, so we just take the reciprocal. So the tangent of theta is equal to root 3 negative root 3, or root 3 over negative 1, whichever you prefer. So now you just have to kind of think about the unit circle and how you're going to get something to work out properly for you. This square root negative root 3 is the same as root 3 over 2 divided by negative 1/2. By the way, you know the answers here are going to be in the second and fourth quadrants here because this is where tangent is negative and also cotangent is negative. So it has to be in these two quadrants. And you just need to think of, well, what's up here? So you can see it's going to be root 3 over 2 to the left and 1/2 up vertical. And that happens to be the coordinate for 2 pi over 3. So this is going to give you theta equals 2 pi over 3. And that's because the sine of 2 pi over 3 is root 3 over 2, and the cosine is negative 1/2. You can see the 2's cancel. So this is just a question of remembering what the sine and cosine look like all around the unit circle. Of course, you could use your calculator, and your calculator is going to give you an answer, but your teacher wants everything done in terms of pi. So I think it's better to just go right from the unit circle. Sometimes they won't say it this way. They'll say, oh, we need an exact answer. So that means you have to, basically, this is the exact answer. You're not allowed to convert this to decimal. So down here in the fourth quadrant, it's just going to be sort of the cousin of the one that's in the second quadrant. But I'll do the workout. So tangent of theta is equal to negative root 3 as before, but now we're just going to move to 5 pi over 3. So when theta is 5 pi over 3, the sine of 5 pi over 3 is negative root 3 over 2, and then the cosine is 1/2. Just remember that the tangent is sine over cosine. That's how you move back and forth between the unit circle and tangent. You just take the sine, which is the y coordinate of the point, and then divide it by the cosine, which is the x coordinate of the point. So our answers are theta equals 2 pi over 3, comma, 5 pi over 3. That's a crazy pi over there. Fix that. Okay, and then, you can check this on your graphing calculator. I also just put it into Desmos. I'm going to download that now so you can see what that looks like. And so this is the graph from Desmos. You really should get used to Desmos. Desmos is going to be available and for your use on the PSAT in October if you're taking that. And if you're taking SAT, it will be available for your use in March of 2024, so it's not that far away. Unfortunately, I can't. You can on Desmos, you can just touch the point and the coordinates come up, and so you'll just have to take my word for it that when you touch this point here, because this is all in decimal, you can see, but when you touch the point on Desmos, you get 2 pi over 3, comma 0. It's one of the features of the product. You just touch that point and the coordinates come up. It's very nice, convenient. And if you touch this point, you're going to get 5 pi over 3, comma 0. And I like to use Desmos because I can upload something to the screen that you could see. And this is the graph of root 3 cotangent of theta plus 1. You can see I'm just looking for the x-intercepts, which are here and here. And that just confirms it's, I think when you're doing it for homework, obviously on a test, you're not allowed to do this, but for homework, it's good to check your answers. And I don't have a handy dandy way of doing it on my calculator and then putting that up into Wyzant. So I hope this explanation was helpful to you, and I'll see you again next time. Bye-bye.